Right, so here we are again for another triangle congruence theorem. Today we're going to be talking about SAS, which is side angle side triangle congruence theorems. And that's going to be on pages 50 and 51. And yes, we will do both again today. We'll do side tomorrow, and then we'll do these two next week. Okay, so go ahead and take a notebook, open it up to page 50 and 51. 50 and 51. So we're going to label those. 5.3 side angle side triangle congruence. You're going to label 50 and 51. Okay. You need to tear out of your book to page 247 and only page 247. Now, what we are cutting out today, you're going to have to be especially careful because we're getting a lot of stuff. It's going to be enough to fill both pages, but it is all going to be from this page, the front and back, which means you got to be really careful. Only cut out exactly what I say and as small as I say it, and do not get rid of the page until the end of this video, because you don't want to have to be hand drawing these triangles. But if you cut it out and get rid of it, you will have to. So the first thing you need is the actual theorem. Okay, then you need the instructions. Could have written those, but anyway. Then you need this set of triangles. And then this set of triangles. Now, the stuff on the other side, on 248, we're going to put on the next page, so don't get rid of this paper. Put it to the side. We will need it in a minute. All right, so we're going to start off with the same kind of thing we did yesterday. We're going to talk about the theorem. We are going to see, based on some actual side links, if they're congruent or not. Then we'll get to the proofs in a minute. So let's just go ahead and glue these in the order we got them here. I'm going to glue in the theorem at the top. Then I'm going to glue in the directions. Glue in this one with A, B, and C first. Skip down to about halfway and glue in this one. I don't know if that's halfway. It doesn't matter. Skip 4 or 5 lines and you're good. Okay, there you go. So today we're talking about SAS, which is side angle side. And that theorem says if two sides and the included angle, included still means in between, it always does. So two sides and the angle in between of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So I'm going to flip back to that sheet we've had for the last day or so. You're going to need to fill this out for side angle side. You're copying this and putting it here. So let's open that one up. Here's what this one has. The side, an angle, and a side. You have to be able to determine which is which. We had angle, side angle, where we had two angles and the side in between. Now we have side angle, side, okay? You have to be able to determine which is which. So let's look and see if we've actually got that going on here. In number 1, we have a side, an angle, and a side, and a side, an angle, and a side. AC is 19, DF is 19, AB is 20, ED is 20, or DE. But A and D are not congruent. So, what are we going to do? We're going to do what we did yesterday. And we're going to say, since angle A, if you remember, is not congruent, congruent symbol with a slash through it is not congruent to angle D, triangle ABC is not congruent to DEF. And we're done with that one. Right, number 2. Okay, number 2. I have a side, they're both 46. I have an angle, they're both 37. I have a side, they're both 74. It does not matter that they are not in the same orientation. We'll fix that when we name it. So we have a side. JL is congruent. J is where 37 is. M is where 37 is. JL, MP. There's our first side. Then our angle. J and M. Okay, then we have another side. Let's see, we already got JL, so JL, MP, JK then. And J to K is congruent to M to N. Okay, so therefore, by side, angle, side, triangle JKL is congruent to, and I really got to think about this, J and M are congruent, so it's M. J to K is M to N, and then P. And I can just look, JKL, J is at 37, we go across the 74 degrees, so M, N, P. Okay, you have to make sure order is correct. So there's what we're working with today, is side, angle, side. Let's do some proofs. We're going to pull this from the back of 247, which is, of course, 248, okay? We have accidentally cut off, I just accidentally cut off some of the instructions, but that's okay. It's not going to matter. And I'll show you why. It's not going to matter. Okay. From 248, you're going to get two things. First one is this. The second one is this. We will glue this one in after we find out how much room we need for this one, okay? So I'm just going to put this one to the side, but here's what it looks like. Cut both of these out. This one and this one. I'm going to zoom out a little bit so you can see them both, but we're not going to glue this one in yet. Put that down. Okay? All right, but we are going to glue this one in. So go ahead and glue that one in. Okay, so we've got our given, we have our prove, and we're going to start with given. Remember, we always are going to start with our given. Okay, that'll be the very first thing we put in our two-column prove. I had to get my black pen. So I'm going to have statements. No idea how many I'm going to have. I'm going to have reasons. I don't know how big to make this table. I might have to make it bigger. I might have to just erase them, make it smaller. Okay, but the first thing we're going to do is write down that BD is the perpendicular bisector. By the way, save some time. Perpendicular symbol is an upside down T, like that, of AC. And that's actually going to tell us a lot of good things there. And the reason is that it is given. You always are going to put that given first, okay? Okay, we'll end with this. So, what do we have? Well, we're going to need a side, an angle, and a side. By the way, some of these it is possible to prove with either side, angle, side, or angle, side, angle. But for today's lesson, since it's side, angle, side, we're only going to prove with side, angle, side. If you get to homework and find that you could actually prove it with angle, side, angle easier, go for it. I don't care. Because eventually, you're going to have to be able to distinguish between them anyway. All right, that means we're going to need an angle. No, we're going to need a side, an angle, and a side. So, we know that BD is the perpendicular bisector of AC. We're going to really hone in on that word bisector. Bisector means it cuts AC in half, meaning AD and CD are congruent. And I have to do AD and CD because AD and DC, I don't want to say that because in order of triangles here, this one and this one would match because this looks like it's a right angle, and it is because it says perpendicular bisector. So number 2, AD is congruent to CD. And that is definition of the bisector. We'll get the perpendicular part in a minute. Okay. I could have written definition of perpendicular bisector. That's fine too. That's not going to change anything. If you wrote that, it's not wrong. All right, there is one side. We still need an angle and we still need a side. Now, we only know something about one angle, and that's this angle right here. Since it says it's the perpendicular bisector, that means both of these are right angles, okay? And I have to write that. Number 3. Angle, and I can't say D because there's more than one angle there. Angle ADB. And angle CDB are right angles right here. That is the symbol for right angles. And that is, again, definition, but it's definition of perpendicular bisector now, because the perpendicular part. Okay? If they're both right angles, they are congruent. You do have to say both pieces in a right angle situation, because it doesn't say that they are congruent until you know their measures are equal or they are right angles. The reason that is all right angles are congruent. That is I forget where that's at. I don't think it's a Euclid element, but it is a theorem, postulate, or something written somewhere. All right angles are congruent. So I've got two angles congruent. So I have a side, I have an angle, I need another side. Specifically, I need the side right here so that I would have side, angle, side. So I'm hoping this side is congruent to this side, and it is. You know why? It's the exact same side. We got to think about order, though. B to D is congruent to B to D. I don't have to switch the order this time like I did yesterday because D is the right angle in both situations. BD is congruent to BD. Why? Because of the reflexive property. You use that one a lot. When I was in geometry, I forgot it so much and would miss everything because I would forget to say it. Here's why I know I have to have that, though. I have to have a side, an angle, and a side congruent to each other to use this theorem, okay? Now, do I have enough? Do I have a side, an angle, and a side? Yes. Therefore, these triangles are congruent, which is my last piece. So it's going to go right here. I just accidentally happened to make enough. That's cool. So triangle BDA is congruent to triangle BDC. That is by the side angle side triangle congruence theorem. Okay. I'm going to glue in the next one. You can, by the way, if you've got all these pieces now, you can throw away that page. We're done with it now that we have all these pieces. Wow. Again, I have no idea how many I need. We'll see. All right, so you are going to need to write the givens first. It does not matter if you write them in the same line or in a separate line. You get to decide. I'll write them in a separate one just to do it. It doesn't matter, though. And then we will have the proof piece. I'll go ahead and start that one on your own, okay? I'll give you a minute or so, but pause the video and go ahead and start it on your own. Okay, number 1 and number 2 will both be givens. CD, there is not a symbol for bisects that I know of. I probably need to find out. AE, that means that AE is cut in half. Given. And AE bisects CD, so CD is also cut in half. Okay, we don't have a side, an angle, or a side given to us. So we've got to find all three of them. So here's what we got. If CD bisects AE, that means AE is cut into two congruent pieces here. So we're going to start with that. So number 3, that's using this first given right here. AB is congruent to EB. That is the definition of a bisector. There's one side. I need another one. I could find the angle. I'm not going to find the angle first. I'm going to find the other side, and here's why. The second given tells us that AE bisects CD. So AE bisects CD. That means CD is cut in half. That means that CB is congruent to DB. And that is also definition of a bisector. All right, let's see what I got. I've got a side and a side. I need an angle. Specifically, I need the angle in between these sides, which would be this one. Are they congruent? Yeah, here's why. They are vertical. Now let's think about naming them. A, B, C. I put triangle. I'm not ready for that. Angle angle ABC. I have to start at E because A to B is got the one segment mark. So I need to go E to B because it's got the one segment mark. E, B, D. Because of the vertical angles theorem. Alright, now let's think it through. Do I have two sides and the angle in between? Yes. So I'm going to skip to the prove part because I'm done. Once I write that down, I've got this done. Triangle ABC is congruent to triangle EBD. Notice they match. They don't always, but we did a pretty good job. 6. Because the side angle side triangle congruence theorem. Now, something you should know, and it's really great why I've highlighted this way, and that's why you should probably highlight it this way too. It's a good example. The numbers 3, 4, and 5, the things that are not highlighted, and the same up here, 2, 3, 4, and 5. Most of them, the order didn't matter. We could have had 1 and 2, and then we could have had number 5, and then number 4, and then number 3. It did not matter. There are certain ones that go together that matter. For instance, I'm going to grab another color. On this one, these two mattered. 3 had to come before 4 because 4 is talking about their congruent because they're right angles. But the other two didn't matter which order they were in. The order does not always matter. That means if you are checking a proof or something, don't think that just because you have it out of order that it has to be out of order. That it has to be in the same order I have. It all depends upon if the one you're using has something to do with the one before it. Like these two, they couldn't be said until you listed the givens, okay? This one could have been said even before the givens because this had nothing to do with the givens. It just had to do with the fact that they're vertical angles. So sometimes the order is not always going to matter. We'll talk about that some more as we keep going through these.